So we'll continue constructing histograms with this example here. This is the Super Bowl example. It says it has been stated that the National Football League, that's the NFL Super Bowl championship, is not that exciting to watch because the games are often one-sided. The following is a list of the final scores of the 50 Super Bowls from Super Bowl 1, that's a Roman numeral 1, to Super Bowl 50, that's the Roman numeral for 50. And of course, that's from 1967 to 2016. So here is the data from the Super Bowls. And as you can see right here, here's Super Bowl 1. That was between the Green Bay Packers and the Kansas City Chiefs. And the score was 35-10. And then it goes to Super Bowl 2, Super Bowl 3, all the way through, and ends up down here with Super Bowl 50 between the Denver Broncos and the Carolina Panthers. And that was a score of 24-10. So it then says, group the Super Bowls into 5 classes based on the margin of victory, that's the difference between the scores, of each team, and determine the frequency distribution. Then construct a histogram of the frequency distribution. So we're going to point out right here, we want 5 classes. So that means there's going to be 5 bars. Each class represents a bar. So maybe the first thing we'll do is we will go ahead and go back to our data here and put in those margins of victory. Now the margin of victory is just the difference between the scores. You can see for Super Bowl 1 here between Green Bay and Kansas City, the score was 35-10. We just subtract one score from the other. So this has a margin of victory of 25 points. For Super Bowl 2 here, between Green Bay and the Oakland Raiders, the score was 33-14. That has a margin of victory of 19 points. So I'm going to put in all the margins of victory since that's the data that we're looking to deal with. So here are all the margins of victory. So then the first step we'll do is we'll put in our number line. Now our number line, as we look at our data, has to go minimally from the smallest data value to at least the largest data value. And as we look through our margins of victory here, right down here, for the New York Giants, this is a Super Bowl 25 between the New York Giants and the Buffalo Bills. There was a score of 20-19 that had a margin of victory of 1. So that's our smallest data value is 1. And as we go through all our data here again, we look for the largest data value, and coincidentally, it just happens to be the Super Bowl just before it, Super Bowl 24, between the San Francisco 49ers and the Denver Broncos. That was a score of 55-10. That had a margin of victory of 45. So our number line has got to go from 1 to at least 45. So I'm going to put that in. So now I have my number line in, going from 1 to at least 45, our largest data value. So then for step 2, we have to determine our class width. Now we're going to have 5 classes. That means within that data from 1 to 45, I have to divide it up into 5 classes, 5 bars. So from 1 to 45, that's a span of 44. We just subtract the smallest data value from the largest data value. Then we're going to divide that by 5. That comes out to be 8.8. Now we do not want a width to be a fractional amount, so we're going to round that up to the next whole number, so that's 9. So this data is going to have a class width of 9, thus being able to show 5 bars or 5 classes. The next thing we're going to do, step 3, is we're going to go ahead and we're going to make the distribution. So we look at our data here. I'm going to put in right here the margin of victory. And then I'll put in the frequency. I'm just going to shorthand it as FREQ. And then I go through this. Our smallest data value is 1, so I'm going to start there. And then I just count off or add on 9 for the next data value to come in. That's going to be our next lower class limit. This is the lower class limit for the first class. This is the lower class limit for the second class. Between consecutive lower class limits, that's our class width. The difference between 1 and 10, that's going to be 9. The next one here will be 19. And then we just keep adding 9. Here's 28. And we add 9. Here's 37. So this will go from 1 to 9. This is our upper class limit. Our upper class limit is the largest data value that's going to be represented in a bar. So we have 9, 18, 27, 36, and 45. And you can see how this breaks up each bar. We then go through here and count up how many there are. For margin of victory between 1 and 9 points, there were 19 Super Bowls that had a margin of victory between 1 and 9 points. There were 17 Super Bowls that had a margin of victory between 10 and 18 points. 8 between 19 and 27 points. 5 between 28 and 36 points, and just 1 that had a margin of victory between 37 and 45 points. And of course, if we were to add these up, 19, 17, 8, 5, and 1, that's going to give us our 50 Super Bowls. So then our final step, step 4, we go ahead and we make the histogram. So I'm going to put in my frequency ledger along the side here. My largest frequency, that's the first class here, that's at 19. So I'll go up maybe 20. Now all we have to do is read our margins of victory here, read our classes here, and put in our frequency. So the span from 1 to 10, from 1 to 10, that's going to be 19. So I'm just going to go ahead and go all the way up to 19 here. And don't forget, this bar is interpreted as from 1 to less than 10. The bars will go from each consecutive lower class limit. However, it's interpreted from 1 to less than 10, or in other words, the points from 1 to 9. Then we'll go from 10 to 19. There's 17 of them. Then we go from 19 to 28, and there were 8. Then from 28 to 37, there were 5. And then the next lowercase limit, if there was another class that was to go on here, that would be at 46. So we go from 37 to 46, and there was just one. So there's the histogram that represents the margins of victory from Super Bowl I to Super Bowl 50.